Hello folks, we come to the part 4 video of the exercise 8.1 and right away let's get to the question and see what the question says. Question says that you have to compare 1.1 raised to 10,000 and 1000 and check which is bigger. So we will go right away for the comparison. There's not much that we can do with this 1000. But this you can expand by binomial theorem and probably that would be helping you to compare as to which is big. So let's check how we can do it. Let's consider 1.1 raised to 10,000. 1, 2, 3, 4, yeah. So that is by form, when we split it up, you can write it as 1 plus 0.1 raised to 10,000. Let me check the number of zeros. Hope there is not many zeros. 1, 2, 3, 4, yeah, 10,000. Yeah. So then we make go in for the expansion NC0. NC0 1 raised to 10,000. 1 raised to anything is itself. So, doesn't matter much. 10,000 C1. 1 raised to 999 and that's really immaterial. 0.1 raised to 1 like that, and then you have terms coming up that way. So, the first term NC0 is always 1. So, this will account to 1. And this NC1 is always n. So, this and 1 raised to anything is just 1 itself. So, doesn't matter. Right. Now, this is 1 and this is 1000. And you have other terms. Right. So, how did it become 1000? Because we multiplied it by 0.1, it became 1000. Now, 1000 plus 1 will become 1001. Plus, other terms are also there. Some positive terms are going to add up and then come up to a number. So, it's very clear to us that 1.1 raised to 1000 is a number which is clearly bigger than 1001 because 1001 plus something is adding up and that's how you get the answer for this. So, it's clearly bigger than 1001, which means it's clearly bigger than, okay, right, yeah. That means it's clearly bigger than 1000, right. So, indirectly 1.1 is bigger than 1000. So, that's how we have, therefore, 1.1 raised to 10,000 is bigger than 1000. That's simply the working of it. Then we go to the 11th question. This can be called as an application kind of question. You know what they say, you have to find out what is a plus b raised to 4 minus a minus b raised to 4. Find it out. Then use that idea to evaluate this. Very good question. Like you use your binomial theorem, first expand it. Get the simplified version. After you've got the simplified version, get the value of whatever is given to us. So, we will not waste any time, right away we will go, except for the fact that whether we know these 4C zeros. 4C0 is 4C4 which is 1, then 4C1 is 4C3 which is what? 4 factorial by 3 factorial into 1 factor, so 4. Oh, why did we do this? NC1 is n, we know. Oh shit. Okay, anyway, this is 4C2. 4C2 is 4 factorial by 2 factorial into 2 factorial. So, this can be written as 2 factorial into 3 into 4 and this is 2 now. So, you have it like 6. Okay, preliminary things we have. Now, let's solve it. So, consider a plus b raised to 4. Let's take it right away. A minus b raised to 4. We have been doing quite a lot of problems now. I think we'll be able to get it. So, 4C0 a raised to 4. 4C1 a cube b. 4C2 a squared b squared. 4C3 ab cube. And 4C4 b raised to 4. Right. Then you have to subtract it from the next expression. Next expression, we just have to be careful that every alternate term will be negative. The term as such is same, only the sign you have to be a little careful. First term is positive, so it's 4C0 a raised to 4. Next term is negative because of the negative sign. 4C1 a cube b. Next term is positive, 4C2 a squared b squared. Now, why that is coming, that negative is coming is because b can be written as plus minus b, and whenever this b will take odd powers, it will also give a negative sign. We have seen it in early expansion problems. That's why these alternate terms are becoming negative. Okay, this is the question as it is, but the problem is there is a minus sign in between. So we know that if there is a minus sign in between, then when we solve, all the signs inside the bracket will change, right? So actually these signs are going to change. Now this will become negative, this will become positive, this will become negative, this will become positive, and this will become negative. So net effect, when you go to solve, you have to consider these signs, because this is the sign that we have got after opening up the bracket and changing the sign. So what will happen? These both are exactly identical terms but negatives. So they will cancel each other. These both have to add up. So 2 times 4c1 a cube b. This will cancel each other because they are negative terms. And these are adding up. So it is becoming 2 times 4c3 ab cube. How we used to write x plus x, 2x, like that. This term plus this term is 2 times that term. Then this is also cancelling luckily. So we are left with only 2 terms, 2 4c1, and this is 4 for us. So actually it is 8a cube b plus 8ab cube, because we have this as 4 into 2, 8. So what has happened? All that big mess has solved and become this 8a cube b plus 8ab cube. Now comes the part where we have to find out the value of, so to evaluate root 3 plus root 2 raised to 4 minus root 3 minus root 2 raised to 4. Now, this is what had happened there. Same thing, a plus b raised to 4 minus a minus b raised to 4 simplified as 8a cube b plus 8ab cube. Same thing will happen here, because we are using that 8 times root 3. A is root 3, b is this. So root 3 cube root 2 and 8 times plus root 3 into root 2 cube. Now what is the meaning of this? Root 3 into root 3, root 3 into root 3 into root 3 into root 2, right? So root 3 into root 3 is 3. That can multiply with this, become 24 root 6. Again, this is root 3 into root 2 into root 2 into root 2. This 2 can become 2. So 8 2s can become 16, and this can become root 6. They are like surds, so they can add up. So 24 plus 16 net effect will come to 40. So your final answer is 40 root 6. The beautiful application of binomial, not only application, actually it's a full-fledged question where they check your understanding about the binomial theorem, whether you are expanding properly, whether you are taking care of the sign properly, they are taking care of your, they are looking if the algebra is being done properly, and then having got this important tool with you, whether you using it properly, you know, the beautiful problem. Everything together, now your knowledge, your understanding, your concept, your application, everything is being checked here. It's a beautiful problem. Next problem is also just that way. It tests all your skills about this problem, about the concept of binomial theorem. Let's go to the next one. Yes, what does it say? X plus 1 raised to 6. You have to, like before, find the values, or rather simplify x plus 1 raised to 6 plus x minus 1 raised to 6, and that you have to use it to solve the given expression. So like what we did here, let's get those ready reckoners here. 6c0 equal to 6c6, which we all know is 1 itself, and 6c1 is 6c5, which is 6, and 6c2 is 6c4. I don't know whether if I remember it, if my remembrance is correct, and 6c3 is 20. This is what I remember. We can also cross check, but I think more or less 90% it's correct. So yes, so these are the values that we have, and if you're not very clear about it, we go back to our roots, get it multiplied, cancel, and get the answer. Okay, quickly we'll go into the expansion like what we did here, but it's not so easy like this. Why? Because 6 raised to 6, so 7 terms are there. We have to be a little careful. So consider x plus 1 raised to 6 plus, let's take this, 6c0 x raised to 6c. Now we are made very matured. 1 raised to anything is 1, so we kind of neglect 1, right? So we are only bothered about the powers of x. 6c1 x raised to 5, 6c2 x raised to 4, 6c3 x raised to 3, 6c4 x squared, then 6c5x and 6c6 x raised to 0, so nothing, 1. Similarly, your next term, same way, 6c0 x raised to 6, only thing wherever there is these alternate terms, they'll get the minus sign because of this plus minus 1. This becomes plus minus 1. So that is carried everywhere. X raised to 5, 6c2 x raised to 4, 6c3 x raised to 3, 6c4 x squared, 6c5 x, 6c6. We could have them cut, right? Our intuition tells us that because the terms are exactly same and signs are different, there are all chances that this can get cut. So let's see what all things can get cut. These are same terms, opposite signs, they'll cut each other. Same terms, opposite signs, cutting each other. Same terms, opposite signs, cutting each other. Now, these both are exactly identical terms, so they add up 2 times 6c0 x raised to 6. Again, 2 times 6c2 x raised to 4. 2 times 6c4 x squared. 2 times 6c6. Like I told you in the previous problem, x plus x is 2x. So also same terms are there. When they add up, it will become 2 times that term. So this is how we are getting it. Now the c's also maybe we will diffuse. This is 1, so it's just x raised to 6. c2 is 15, so it's 30x raised to 4. And this is also, so that is 30x squared. And this is of course 1, so it's 2. This is what we get, like what we got over there. Now we are ready to evaluate. So to evaluate root 2 plus 1 raised to 6 plus root 2 minus 1 raised to 6. So your x is root 2. That's what we understand, isn't it? So that will be by this formula 2 times root 2 raised to 6 and 30 root 2 raised to 4. 30 root 2 squared plus 2. So more carefully, it is 2 raised to half. So 2 raised to half into 6. 30 into 2 raised to 1 half into 4. 30 into 2 raised to half into 2. Right. So you're getting 2 cube here. Sorry, you're getting 2 squared here. Yeah, so finally what we're getting, 2 into 2 cube, 8 into 2, 16. Then this is 2 squared, that means 4, 120. Then this is 2 into 30, 60. And this is 2 itself. This is 180. 180 and 16, 196, 198. Your answer that comes up is 198. Beautiful problems. These two are the best problems because they're testing everything about binomial theorem over here. That is about this part number 4. Now 2 more problems are left that we're taking in the next part. Thank you.